I'm gonna fail my physics test in this next class, and I have a huge soccer game after school, so I'm already stressed.
No, Gabby, you'll be fine. You got this.
I'm just gonna study.
Whoa! Is it game time?
No, Gabby, it's physics time.
Oh, brother.
Let's get started at the beginning. Newton's first law states that an object at rest tends to stay at rest, and an object in motion tends to move with a magnitude and constant velocity.
That's so confusing.
It might sound confusing, but you've been using this law in every soccer game you've ever played.
What?
Think about it. Before the ref blows the whistle, you're moving at a velocity of
0, I guess.
And when he blows the whistle, do you want to keep moving at that velocity?
No, the other team will get the ball.
Exactly. So what do? You apply a net force to yourself to get yourself to go.
Duh, everyone knows you need to apply a force to move.
So show me.
Okay. But that's just a simple fact. That's not gonna help me on my test at all.
Look at your ball.
Okay.
What velocity is it moving?
0.
So to get it into the goal, what velocity does it have to be moving? Not 0. How are you going to do that?
I'll kick it.
Exactly. You needed to apply a net force to the ball to get it from moving at 0 to a higher velocity to get it in the goal.
All right.
Newton's second law is just as easy as the first. It states that the more force you apply to an object, the more it will accelerate. It is represented in the equation force equals mass times acceleration, or F equals m times a. So basically, the harder you kick the ball, the farther it will go.
Well, duh.
Now, what if that ball was twice as heavy?
That would be terrible.
Why?
Because then I would have to kick it harder to get to the same distance.
Exactly! Newton's third and final law states that for every action there is an equal and opposite reaction. This means that every single time you kick or head the ball, you're exerting as much force on the ball as it is exerting on you.
It really makes no sense at all. I am huge and that ball is tiny.
So what do you think then, Gabby, that you're exerting more force on the ball than it is on you?
Sounds about right to me.
Wrong! You seemed okay with the second law.
Yeah, as mass increases, so does the amount of force. And as mass decreases, the amount of acceleration increases because of the equation F equals ma.
How would we just do a little break there? Now what happens to the ball when you kick it?
It moves away from me.
Not only does it move, but it accelerates. Do you move and accelerate when you hit it?
No.
Exactly. That's because of the equation you just told us about. F equals m times a.
Oh, that makes so much more sense. I'm feeling good about this physics test and my game.
Yeah!
Gabby, wake up. It's time for your physics test.
It's go time.